Good afternoon. This is Mini Lecture E, and it is our semester wrap. Let's take a look at where we started. We started with crusty old Galileo, whose admonition was to observe and think about what you've seen. And we ended by talking about uh, Katherine Johnson, the brains of the NASA computer operation. Galileo famously said, and it's something that we have to keep in mind, that the universe is a grand book, continually open to our gaze. And we stand at the shoreline of an enormous universe. We want to try to make sense of it. One of the ways that we make sense of it, try to speak the truth about it, is through the physical scientific method. We started with cinchy stuff. We started talking about what does a baseball do in free fall. Here's a famous image from a long home run from back in the 1950s, Mickey Mantle. We even talked about golf shots that we could see on TV. Another thing that we talked about was heat energy, and how heat energy and convection can, if it's not in thermal equilibrium, can lead to storms. We studied waves and oscillatory behavior. Here's waves in the ocean. I love that image. But what we really wanted to understand was the waves that are produced, especially by quantum particles like electrons. Because if you do that, you can figure out the interaction of molecules to form, for instance, crystals like this crystal of H2O, water, and even um, droplets of liquid water. They have cohesive forces too. The hydrogen bonding between water molecules produces the surface tension that helps them form circular droplets. Rain, when it's dropping through the air, is pretty close to circular, or spherical, I should say, until it gets really fast and then it gets deformed away from a sphere. But yeah, they're spherical, and that's because of the hydrogen bonding and the cohesive forces. And then, of course, here's our final image, the X-ray diffraction image, photo 51 of DNA. Now, through all of this, we swam through a small sea of equations, formulas, all of them leading to an understanding of the quantum world. And especially to the idea that Planck's constant is the constant that rules them all. So as we finish this semester, I challenge you, let's follow Galileo and Rosalind Franklin and Katherine Johnson and all the other greats. And let's keep our eyes open and keep walking and keep learning about the physical universe.